and welcome to today's webinar, Improve the Cyber Defense of Your Operational Technology. My name is Tracy Purdom, and I am the Executive Editor of Chemical Processing, which is producing this event. This event is sponsored by Dragos Incorporated. Chemical makers face increasing cybersecurity threats to their industrial control systems and operational technology. However, companies can take many steps to strengthen their cyber defense and establish capabilities to lower their cyber risk. In this webinar, we will explore trends in cybersecurity threats and provide insights on how to enhance your cyber posture. This discussion is based on questions we received prior to the event, but please don't hesitate to add additional questions as they occur to you. Now, before I introduce our speaker today, there are a few housekeeping issues that I'd like to review for you. On your screen, you should see several sections, and I will highlight a few of those. In the largest section is where today's presentation slides will be displayed. To the left is a Ask a Question and Tech Support box. At any time during today's presentation, you can type your question for our subject matter experts right here, and we'll address those. And if you're having technical problems, you can simply type in your question or concern, and one of our technical engineers will assist you. To the right is our handouts area. You'll find today's slide deck as well as an additional resource, so feel free to download that as well. If you need a better view, you can enlarge a section by clicking on the box in the top right corner of the section. If you accidentally close out of a section, you can get it back by clicking on the colorful icons at the bottom of the screen. Hover over those and they will tell you what they are. This webcast will be archived. We encourage you to direct coworkers to the recorded presentation. It'll be available at chemicalprocessing.com's website. We will also send out a link via email so that you can access that as well. And one final note, we ask that you respond to an exit survey at the end of the event. Your answers always help us to improve future events. And now I'd like to introduce today's experts. Joining us is Mike Hoffman. Mike is a principal industrial consultant at Dragos, where he serves as the primary subject matter expert with customers to perform architecture assessments, network vulnerability assessments, and consequence-driven modeling of their industrial environment. Before joining Dragos, Mike was a global principal ICS security engineer at Shell and held the role of ICS security region. Also joining us today is Oscar Delgado. Oscar is a senior industrial consultant at Dragos, where he is the primary SME who interfaces with customers to perform architectural assessments, network vulnerability assessments, consequence-driven modeling of industrial environments, gap analysis, tabletop exercises, and a range of other customer-facing activities. Over the past 14 years, he has been directly involved in the update and or expansion of CPFs, refineries, and petrochemical plants. He previously assisted the conception, construction, and commissioning of water and wastewater treatment plants in the U.S. and Canada. Additionally, Oscar has worked in oil drilling operations and mining. Welcome to you both. Incredible dossiers. I'm looking forward to our conversation here today.
Awesome. Well, thank you so much. And I will get it kind of kicked off here. But before we kind of move forward within the slides, kind of talk a little bit about Dragos, which is coming on up on the next slide here. And so essentially with Dragos, kind of who we are, many people from a security, OT security realm may have heard of this before, but I just want to quickly, before we get into the Q&A section on some of those questions that came up, talk a little bit about our company and what we do so you'll have a little bit of understanding. So Dragos is a technology company. So what we do is we have a product that monitors network traffic and so forth, is able to provide visibility within OT environments around being able to understand how your systems work, and with that, not only understand how they work, but identify different types of activities that may be occurring with the environment. And we a lot of times we'll call these like an adversarial type of an activity, where the platform may be able to see and find different types of threats that are coming into the environment. Maybe your a DCS system at your chemical plant or whatever, and that's essentially how that works. A lot more to that, but apart from a product is we also have services. So Oscar and myself are on a services team, and so what you heard in the intro from our roles and those kind of things is we go out and we help customers doing architecture reviews, tabletop assessments, vulnerability assessments. Other teams will do pen testing, incident response, and those kind of things. So that's on the services side. We also have a intelligence perspective as well. So we have teams that are out there looking forward, looking throughout the internet, scouring different things, understanding the different types of activity groups or threat actors, as we would call them, that are actually trying to target these critical infrastructure environments. And so that those teams essentially go out and view, monitor, report on, and provide intelligence for end users, asset owners, and operators to be able to digest that information and really to better understand what kinds of adversaries are against them and their systems and plants, and then how to better equip themselves to deal with that. Also, we have a community piece as well, where we have multiple different aspects of the community portion of that, and then also on the outreach piece, kind of what we're doing here in this webinar, trying to build up the community and trying to, again, share lessons learned, baseline practices that we've seen, and so forth. So a little bit about Dragos, a multi-pronged organization, kind of all though uplifts, if you will, our platform and our technology and our capabilities from that perspective. So with that, a little bit about Dragos, and now we can get into some of the Q&A.
That sounds great. And I'm going to kick it off with something I think that we need to kind of set the tone for a little bit is what are some of the key differences between IT and OT cybersecurity?
Yeah, that is a foundational question, the one that I get asked often. And I'll take this first in areas where I may not have fully looked at it. Oscar can maybe help out a little bit. One of the major differences, though, so when you consider IT and OT, so a lot of times you may hear that, hey, OT systems just look like IT, and that may be very true. What the main difference and the principal difference between OT and IT, so IT is an information technology, OT is operational technology. So when we think about OT, what we're actually thinking about is systems, and they're actually controlling your plant, and they have a capability and an impact to perform some sort of a operational or physical change to the environment. So really the difference is the overall, the mission of that system. So you could place a server in an IT environment, and that server could be running a database, running an HR application, running something like that, email, or you could take that same piece of hardware and put on a DCS type of an application, and it runs your plant, and it runs your control system. So it's taking similar hardware, but a completely different mission and use case and so forth. So and then of course that's the IT-ish side of the OT, because we're using a lot of the same. Number of years ago, back in when Windows, it seemed like around NT 2000 came out. That's really where we saw that major shift, where some of the DCS vendors became, actually embracing, because of user feedback in the community, embracing some of these technologies, and so our once really, if you will, proprietary systems became a little bit more open and felt a little bit more IT-ish. So now in 2022, fast forward, our systems, if you walk into a control room, look very similar to an IT system. But it's the mission and it's the impact of that system is what's fundamentally significantly different. So if you take a system, an OT system offline, if you patch it, reboot it, or something like that, you may have a operational impact. It may trip your unit. It may trip that environment. It may lose loss of visibility to the operations. So all of those type of things really begin to encompass that. What is the difference? It's the impact. It's if this system goes down. What is the significance of HSSE, health, safety, environmental? All those kind of things kind of come into play when we think about an OT system. Oscar, maybe you have some other areas to add on that one.
No, I think I totally agree. I just want to mention that for me, the experience was a little bit on the other way. So I started learning about the OT components. So for me, it was first learning about the valves, then the OT components, and then realizing that the IT were using some of the same components. So I said, oh, we have the switches. And oh, IT also has switches. And then start looking at those. For me, definitely is the impact. I think every time I think OT, I know that at the end, there is some physical system related, right? And sometimes I'm not trying to minimize by any means the importance of IT, but I think that every time I think about OT, I know there is something. It could be a chemical plant, it could be water treatment plant, it could be a refinery, something that is tied, that is physical, and that you can see. And for me, something usually that's something of very, very important. And also that brings to the second point, and it's how you design those things. So you mentioned the purpose, and I want to touch a little bit about the life cycle. So when you start looking at the equipment that you deploy for industry, they usually are like 20, 25 years. I will say that's typical, the life cycle of equipment. And even if you don't associate the OT with those 25 years, you still have like a big chunk that you expect your controller, your surface to operate. So that brings another set of different questions. It's like, okay, is this going to operate for 10 years? Is going to provide, I need to provide support for 10 years. So it's not the same pace as IT. I remember, for example, in a previous job, my laptop, my corporate laptop, it was replaced like every 2 years. I received a new one. But the laptop and the controllers are the things, all the assets that we use for the control. The replacement, the updates were way slower. So things like that are in my mind, the main difference between IT and OT.
Now, this might be a silly question, but can it get muddy between IT and OT? You're saying that they share things. So can you be doing something in IT and then inadvertently impact OT?
Yeah, absolutely. So we kind of have seen some of these around some of the ransomware. I'll bring up Colonial Pipeline. I know this is a chemical-focused discussion here, but nevertheless, chemical sites have pipelines and so forth. So this is a very pertinent discussion as well. But there you saw a ransomware attack that happened on the IT side, and due to taking the safe approach of doing a disconnection between your OT and your IT systems. When that occurred, that disconnect occurred, which was a good response from an IR incident response perspective. But in doing so, they lost the capability of billing out to their customers. And so even though we see, and it's a great question because we, as we move forward, the interconnection between OT and IT systems is just growing. So, we have, a lot more, information flow back and forth between, and that information flow may be trying to do, digital twins and modeling. That could be trying to do historization maybe for, process improvement or advanced process control. Could be for environmental, where you're having to do environmental calculations and push that data across. So even doing a manipulation on the IT side now could have an impact, and it may not be a control impact, but it may be a long-term impact where in certain countries, for instance, if you lose the ability to report environmental data, you actually have to shut that plant down. And so by severing the connection between OT and IT, and by cutting that information flow off, the plant still is operational, but after a while you hit environmental and regulatory issues, where permitting issues, where you actually have to shut the plant down. So yes, and it does get very, very murky between the different the boundary, if you will, between IT and OT. So absolutely.
Now, you brought up Colonial Pipeline and the ransomware as one of the cybersecurity risks. Somebody wants to know a little bit more about what other risks that they potentially can face.
Yeah, one of the things around risks, so Of course, when you think about with plants and chemical plants and so forth, and Oscar can, I'm sure, add in a lot of color on this. But essentially, you have risk to safety. So unfortunately, so as we've come along this journey of making, of essentially taking off-the-shelf products to build out our control systems, what we've done is allowed vulnerabilities, and I'm talking about, you'll hear on the news all the time, you need to patch your Windows device, or name your operating system, it will have a vulnerability or an application, such as Word or Excel or Adobe. Anything that people create, somebody will find a vulnerability in it. But by taking an OT system and taking off-the-shelf products that is used in the IT, we have now inherited vulnerabilities. And so those vulnerabilities can be exploited, of course, by an adversary. But the issue is there, like I said, on the OT side, where you have these impacts, is now we have, in many cases, taken your distributed control system. We've taken that system and we've networked it up or close to maybe a SIS, or a safety instrumented system. And so now we have connected two components together, and so now we have created this area where an attacker could actually come in, manipulate your base layer controller, your DCS, and then if the systems are networked together, begin to manipulate your safety system. And that attack has actually already been played out in the industry with the Tricon attack for a refinery in Saudi Arabia, where the adversary actually came in and began to manipulate and downloaded, I should say, a different set of firmware to a Triconic system, and then began to, and never fully carried out the attack, but there were signs of where that attack was actually now going to the DCS. So you had where you're taking away your ability to, for your safety system to respond, and now you're going to drive that DCS system outside of its operational window or envelope and cause a major impact. So that's one of the things. And maybe, Oscar, around safety, I may pause there because there's many others, but maybe that's a good spot to pause, and if you have anything else to add.
Yeah, I will say that obviously that depends a lot of what is the company is doing, what is the end product, and also what is the raw materials for that. Usually there is also the thief of intellectual property, right? So there is a company that is making this awesome product, and sometimes it's, okay, where is located the information or the recipe to make that product? Is located IT or the IT component? It's something that you program in your controllers. How is getting that? And it's at risk for the environment. What will happen if an adversary or just the competence, they get the information and they start making the same product? So there, definitely the safety, I think, is paramount for any company. And so far, I haven't seen any company that doesn't say, okay, the safety of our employees and the community is not the main focus of everything. And I think that's part also of the design. Then we have the intellectual property. I will also talk about probably the disruption or the environmental damage when you have all the incidents with chemical plants. And then there are other consequences that you will say, okay, they are not as direct, but you will need to face it. So, for example, if there is in the news that the X company released some toxic material to the environment, maybe there was no a clear, direct impact, like immediate, but you will have to clean, you will have to monitor, then you have to, there is a lot of things that you will need to do in order to control that. So all those are risks that they are facing the companies nowadays.
Yeah, and I may touch upon just really quickly the intellectual property component. The chemical industry is one, and you folks that are in it fully know that a lot of your processes are have a lot of R&D work behind them, and your companies are making the profit because of exceptional R&D, and you're keeping that R&D close, tight. It's intellectual property. So I've actually been on numerous assessments where As in Dragos, what we do is we actually will go and begin to have the discussions about what is your most valuable thing within the site that you have. And what we're really looking for is from that process perspective. So maybe it's a compressor, or maybe even your utility system, such as your cooling water or boilers, steam or instrument air to your plants or so forth. Trying to identify those critical systems that if they're compromised could actually have a plant-wide outage. It's kind of a crown jewel approach. In that discussion, though, oftentimes what will come up, though, is that, by the way, we could actually, deal with some sort of a major plant outage. What we can't deal with, though, is if somebody stole our intellectual property, and it may be for that process, how that process is how it's running, the parameters it's running under, or maybe like under a certain catalyst that is being used, or actually catalyst creation in some industries. So I found actually multiple times, and especially true in this industry in particular, is that the intellectual property is, and actually the confidentiality of your information is by far the most important. That doesn't downplay the other aspects of security. So what's funny then is a lot of times people will have a discussion about the security triangle. So for those who are in security, you have the three legs of security, if you will. There's a fourth in OT, but in traditional IT security, you have confidentiality. I'm trying to protect my information. You have availability, so I need it up and running as much of the time. And then you have integrity. We need to make sure that the data that we're seeing and acting upon is accurate and has not been changed. So those are kind of the three pillars of security. And OT, it's also safety. So you have that fourth pillar. And so the safety is the process safety aspect. So with chemical, oftentimes that confidentiality of that intellectual property, and then the safety element actually becomes paramount. And those are the two things people will actually look to when they're developing mitigations or things that they need to work on or improve upon.
Now, we have a question here that fits into this a little bit, and it's a good question. How critical is it to segregate SIS and the business planning control system in refinery or a chemical plant? In your experience, have you seen direct or remote access to the SIS and the corporate IT side? If so, how would you mitigate this kind of risk?
I would like to take this one. So I think the segregation, the network segmentation is one of the main recommendations when we complete architecture reviews. And the idea is, and I will say that it's a question, is there a reason that you need from the IT, from the business side, to actually be able to control a PLC or to interact with one PLC or with one controller? And I will say 99% of the time is no, we actually don't need to. We need data, and that's understandable. They need data to drive the business. They need data to start talking with providers, with clients, and that's understandable. And you need some data from the process. But I will argue that somebody that is, I don't know, making projection or forecasting for the business doesn't need to actually go and be able to change something in the PLC. That's I cannot say there is a reason for that. So we say segmentation is very, very important, and also is a way to create something about what we call the defensible architecture, right? So you want to have an environment that you can, as a defender, you can protect. So making sure, like, okay, if for some reason somebody is able to breach the perimeter of the company and they reach IT, I can contain the attack into the IT, and I am not affecting OT. So I can be sure, like, yes, for example, I have, I don't know, ransomware, and I'm compromised, I have difficulties, but that is not compromising the other part. I'm not concerned that it will affect the safety of one equipment. I'm not concerned that I will be affecting the quality of my production. So it's kind of separating those and making sure that I start building an architecture that I can say, yeah, from that point on, I'm comfortable. I know how to address that any type of a threat that is coming into here, and just preparing the field, making sure that okay, this is something that I can defend. Mike, you want to add something?
Yeah, absolutely. No, that's a great response there. So one of the things, yeah, so first of all, the importance of it can't be understated because of what we've seen. I mean, we've seen now, it's well documented, and our company and others within the OT space have done a lot of research around the safety system and that Triconics, that Triconics attack. And so a lot of the learnings came out from that is the segmentation that you need to do is between the SIS system and the DCS. So a lot of times that the communication between the two systems needs to be such that oftentimes the DCS needs to pull values from the SAS, but it can do so just using maybe reads. So within protocols, I don't want to get too in the weeds right now, but ways to do it can vary, but essentially it's locking down and only allowing what is required within the network and the architecture for that function to work. So most of the time you're only needing to read values from the safety controller and to further enhance an operational display. I've seen a couple times where they have actually, engineers, process control engineers have actually allowed an SIS between, using some rights to it to essentially allow it to step through maybe a startup process. So you are, maybe starting your unit up, and so you allow that SAS to step through different changes or different phases of starting the unit up, and those are so it'll allow a couple of rights to it. Normally, though, we try to see a segmented as much as possible, maybe an industrial firewall between the SIS and the DCS, and then the engineering workstation is yet another piece. So that engineering workstation is normally a computer, normally in your control room or out in a remote field office, and that computer a lot of times is directly connected to that SAS. But a lot of times we see those safety instrumented workstations connected back also to a network, which provides an alternate path for the adversary to get onto that workstation and then upload and download files to that controller. And that's exactly actually what happened on that Triconics attack, where the adversary actually went to the workstation to manipulate, to upload, download files, and then actually get on and actually modify that, that Triconics safety system. So there are definitely ways to do it and do it smartly with segmentation, of course, leveraging good remote access capabilities. I've only seen really a few cases where people have actually been allowed to remote in and view. So like and again, this is coming away from chemical a little bit, but like in an offshore rig where the risk of somebody going out there, flying out to an offshore rig with a helicopter ride and so forth were such that they actually needed to, and from a fairly secure way, get in there and actually view what was going on in that safety controller. But that is a very edge case. So trying to take that back a little bit and greatly restrict access to the safety controller is extremely important.
All right, we have another question here, wondering about a better zone of reinforcement that cybersecurity engineers can provide to better protect the OT network from attacks. Is there such a thing? Is there such reinforcement?
Oscar, do you have any thoughts on that one? I'm trying to understand this zone of reinforcement. I'm not sure what is the goal of the question. I don't think I understand very well what's meant by that.
Yeah, exactly. So I'll answer it how I think the question that is asked, and I may be wrong, but essentially, kind of what Oscar touched on a little bit about building out a defensible architecture. So I'm gonna answer it this way, and it may be slightly off, but essentially, though, what we're talking about is creating a defensible architecture is one that you can, first of all, you can put in security measures. We call them in the OT space security controls. So this isn't process control like your PID controller in a base layer control loop. This is a security control, which is like a firewall or a network monitoring solution you can put in place. So what you're doing though is you're building out your network. A lot of people are familiar with the Purdue model. Building out a network such as that, leveraging different standards such as IEC 62443, where it talks about an architecture where it builds out zones and conduits. What that's doing is building out an architecture such that you can put firewalls in place to block traffic. You can put network monitoring, devices within the traffic so you can view in and see your traffic. So from a defensible perspective, it allows you to see what's going on and quickly take action upon it. So part of that looks like, building out a network between IT and OT using some sort of a DMZ or demilitarized zone. So you're not allowing traffic directly from OT to IT or vice versa. So traffic will come in and terminate in some systems in a DMZ and go through. Next is as you go down, you're not building out flat, wide networks where one computer can talk to all computers. What you're doing is you're segmenting up your network, which allows you to put in these different security controls within inside to view, to respond, to act. And so hopefully that's what we mean by that. So hopefully that answered the question a little bit better.
All right, good advice there. Another question, and this is interesting, how can you determine if a system problem is equipment failure or a potential cyber attack?
I would like to take the lead on this one. And the answer is I don't think you will ever can answer that question just with data. I think it depends. It's a very, very difficult question. And in my experience, it will take a lot of inputs. So usually what I've seen is normally when we evidence some type of failure, like a valve that is not working, a pump that is not working, we usually tend to associate those to equipment failure or some type of issue with equipment, which are normal, right? That is possible that those are caused by an adversary. In some cases, yes. The probability of that, it will be very difficult to know. I think that at some point it's not that important to know, it's caused because the actual equipment is failing, because it's old, because it needs maintenance, or it's caused by an adversary. I think probably it's more important to know what to do about that and how to start addressing, right? And I've seen different approaches. So for example, sometimes they say, okay, our first triage is to consult with the operators, right? The people that are day-to-day operating that system. They usually know really, really well, if there is this valve that usually fails because there is fouling in the system, and every 6 or 10 months we need to do something with this valve. So those are things that they are familiar, right? But suddenly there is one component that never fails. Okay, it's something new, it's something that we need to address. And they will usually be the first kind of triage to knowing. And what I've seen is that there is usually a concurrency between the cyber aspect and the operational aspect, and both try to get at the root cause analysis, right? And sometimes they are simultaneous evaluations. So the maintenance and the operations team start looking okay, what is the history of this valve? Well, when was that the last time that we did a maintenance on this valve? And at the same time, the cybersecurity team is, okay, what is controlling this valve? Where are seeing the data that they provide on and off or adjust the position of this valve? And both are looking at the data that they have and trying to see what is the most possible explanation. Again, as I said, sometimes it will be impossible to say exactly why that failed. Or it will be possible to say just way after the incident happened and needs to be resolved. And I think at that point is, do we have, or the plan has a plan in place to address those failures? And then we can go back to the consequence analysis that Mike was mentioning before, that when we say, okay, what will be the worst case scenario in terms of operation for us, and knowing if we are prepared for addressing those or not.
Now, what about... are cyber attacks always evident? I mean, things could be happening that operators don't realize are happening. Is that an instance, or is it always evident that you're under attack?
I would say there is always evidence. The problem is where you are able to see that evidence and to use that evidence. So every time you interact with a system, there is some trace. Even if you try to delete logs and remove the trace, there is a trace about that. So I think there is always an evidence. The concern is that sometimes you don't have the preparation for that. So there is not a specific incident response plan. There is not a specific collection management framework. So you are not prepared to get that evidence. So sometimes it's like, okay, for example, I want to know if there is any anomaly in this communication with a specific controller, but I don't have the data that goes that far. I have only maybe 1 week of data, and maybe this interaction was 1 month ago. So, okay, there is one evidence, but at this point, this is not accessible to me. Mike, you want to add anything here?
Yeah, no, really good. So I want to hit on one thing that you said that really resonated with me was around lack of being able to identify. And so one of the things, and honestly, one of the reasons why I work for a company that does monitoring is because in a former life I was, over a plant doing a plant security role, and so over a mid-sized refinery. So my background actually is instrumentation, automation, analytical, SIMS and process analytics. So I've been able to come up through the ranks, if you will, and see and really think about impacts to systems, how they should run, those kind of things, just kind of from that instrumentation perspective on up. With that said, one of the major challenges that I faced when I was, a lot of these things were, the cyber attacks and all those kind of things were kind of just being made known many years ago. And but nevertheless, one of the things that really kept me up at night was I did not have the ability in my site that I was in charge of from a security perspective. I could not tell easily what was actually going on. So when I say that, it's from that monitoring perspective. So at that time, not having a visibility of logs. So what Oscar said, anytime an operator interacts with a system, so changing a set point, changing an output, most of your control systems are going to log that somewhere. There's evidence being generated everywhere within our systems. So operations and control systems folks are very used to dealing with that evidence when they're dealing with process upsets and so forth. From that security perspective, that evidence is there as well, even using some of the same sources, but we look at it a little bit differently. But nevertheless, being able to have that that information and being able to pull it back. And what I mean by that is like looking at Windows logs from your environment, and not just Windows logs, but device logs. Being able to pull that back into some centralized visibility perspective. More importantly than getting logs from this hosts, because not all of them do it very well, and we may have some very old systems out there, it's actually monitoring the network traffic. Because that allows you to see what systems are talking to who, what protocols or how are they talking to each other, and then also sometimes what commands are actually being issued. So by looking down into the network, you can identify that is this device having problems because too many systems are talking to it at once, or is this actually an adversarial type of an activity where there's a threat actor coming in and doing something? A little story here is that when I began the journey of getting network visibility in one of the sites I was working on, I was actually supporting another site, went there, I poked in and began to monitor some traffic. And quickly I identified that there were essentially just way too many historian collectors that were coming down and reading off of a DCS node. And essentially what was going on is this DCS server kept tripping off. And operationally, they didn't know why. They just go restart the application, and it would just start functioning again. But until I was able to actually see in the network and see all these things, and once I saw these connections coming through, how much bandwidth these applications were taking on this little application on the DCS server, I quickly went back to the operational control engineers and asked, is this how this should be configured? And lo and behold, there was actually a configuration error, and too many of them were reading down in. So by getting visibility, you not only allows you to see the difference between operational or from that adversarial perspective, but it also allows you to see from that operational perspective of, are my systems actually configured correctly? Do I actually understand how my system is actually working at that level? And so for me, that was a massive game changer, and actually seeing that the visibility there. So yes, I think you can determine if it's adversarial or not, but you have to be looking, and you have to have the right tooling in place to do so.
All right. Now, here's this can be a complex or a very simple answer, or a mix of both. But can chemical manufacturers, what can they do to protect themselves against cyber threats?
And I'm going to start with this, and we've actually covered a couple of these things already. But I think this is a good venture into something that we as Andregos have been kind of promoting some simple, maybe not simple, but some key steps that people can take. And I think the first one is really developing an incident response plan. And I'll let Oscar do kind of the next one here, but really the incident response plan, I think, is by far the most important, because today, after this call, your plan actually may come under attack. We don't know. Having the ability and being able to plan for, and a type of like a ransomware event, or a certain type of malicious type of activity going on with you in your site is extremely important. I find a lot of times people, from an operational perspective, have very, very good plans. From an operations perspective, they know how to recover their units. If something trips, if a compressor trips offline, there are procedures there to go restart that compressor, get unit flows back up and running, get your product on spec, and back to working. That same idea can be carried over into a cyber incident response plan. On if you do see something going on in your sites, how do you begin to, first of all, how do you know? How do you identify that? And then you go into being able to stand up and activate and that plan, being able to pull in the right teams to help respond to it, maybe vendors to help out. And then, of course, trying to understand if you have that right architecture in place to contain what may be going on, and then finally getting rid of that and recovering your systems back. The elements of an incident response plan are extremely important, though, and it's one of the things that it doesn't take to develop this plan, and it doesn't take from a engineering cost. It's pretty light, but to actually implement it, it's a cultural thing. It requires people, knowledge, skills, and capabilities to actually carry it out. But people today, after this call, can actually go start building out that plan if you don't already have it. And I think that's fundamentally one of the first things that people can do and make sure they have it. And once they have it, then they can actually test on it. And we call this like a tabletop type of an activity where we kind of go through a type of a facilitated discussion, and people can do this in their sites. I've seen it done many times in-house, where you'll just go through a type of a discussion and saying, what if this happens, and let's go through our plan. Very similar to like it's something that you do for a CFATS type of engagement on the physical side, doing a tabletop to test that out. So I think incident response is extremely important. Oscar, maybe you could take the next one we spoke before.
Yeah. So I think we already mentioned this a little bit about the defensible architecture, and it's basically making sure that your environment is something that you know, and that it prevents as much of the cyber risk as possible, right? One thing is there is no environment, there is no defensible environment without the human component. So there is always somebody looking, like Mike was mentioning a little bit about monitoring. Okay, but there is somebody at the other end looking at that, and where you want to put the monitoring is something that you want to identify, that you want to learn, and what to do about that. And there are several components, but is making sure that the environment that you're using, that it is known for you and is preventing the risk. I will say that the following question is, how do you make this defensible architecture? And there are several ways to do it, right? And I think I don't want to recommend anything in specific. We are very used to the segmentation, and we will see, okay, the firewalls, and I mentioned, okay, I would like to segment the IT from the OT, but there are many ways to do it. I've seen the micro segmentation, I've seen several tools, but the idea, I think, at the end is the same. Is you want to achieve something that you are comfortable with, and it helps you to reduce the risk, that you can monitor, that you have the visibility. So it's something that you actually can defend, and not something strange to you. I wish a little bit of visibility. I don't know, Mike, if you want to expand on that one.
Yeah, so, and I think one of the other things as well, well, we kind of hit on defensible architecture is around when we described like putting in a DMZ if you don't already have one, but making sure within that the militarized zone, because a lot of times you set that up for moving information back and forth. Now that information may be system-to-system communication, so you may be moving historical data on your process or enterprise historian, back and forth, hopefully out. Nevertheless, so there's a system-to-system, and then there's also user-to-system communication. And that user-to-system communication is one of the areas where adversaries like to attack. And so when we think about building out that capability of allowing our users to, and when I say users, it may be contractors that are supporting the site. It may be your process control engineers that are sitting on the IT side but need to get in and to remotely work on some of their systems. What I'm talking about is a user-to-system access, or a remote type of a connection. And so with these remote connections, there are many ways you can do them. Some are completely insecure and some are more secure. So leveraging things such as like multi-factor authentication, which allows you from that IT side to come into the DMZ, come into what's called like a jump server, and then there do a second form of authentication and then go down within to the other environment. What that does is that breaks the connection between accounts, and it really raises the bar on the adversary on how they can try to attack that system. Now so some of you may be going, multi-factor, what is that? So I'm sure a lot of you have logged into a web form lately, and it'll send you like an SMS message to your phone with a little number that you have to type in to verify that that's you. That is, in its simplest form, multi-factor. So it's something that you have and something that you know. So something you know is your password, something you have is that information that comes back. And so making sure that your remote systems, where you have that user to system access coming from like an IT side to the OT side, making sure that that has some sort of a multi-factor authentication within that piece is really, really important. Again, very raising the bar on trying for an adversary to get in.
I would like to take the last one, if you don't mind, Mike.
Yeah.
And we discussed 5, and the last one we usually mention is the key vulnerability management. For me, this is close to heart. I was process engineer for a couple of years. And this is every device, I think, if you look, you can find a vulnerability. I think that will be a rule. The thing is, in OT, I will say it isn't not as easy as in IT sometimes. It's not like, oh, I can just receive the alert, get the next Tuesday, and I'm going to deploy patches. It doesn't work like that in OT. And there are several reasons for that. So they are like, okay, actually, you cannot take the system off for patching for, I don't know, sometimes years, months. That depends on the criticality of the system. So it's not like, oh, yeah, I can take it off and just apply the patches and restart it. It's not like that. So you have specific windows that you need to do planning. There is others about the compatibility of the system, right? So it says, okay, I'm sorry, but I need the vendor to authorize this patch before I can actually deploy it, because we have an agreement and I cannot install anything without the approval, or because if I update the system, then there are other systems that are depending on this one that won't work as well. So we need to do this analysis. Also, sometimes it's, okay, maybe patching is not available, or it's not even the most cost-effective solution, right? Sometimes it's like, yeah, I can receive all those many patches. So, but I do actually need to go and start going and applying one by one, or maybe there are other integration or security controls, for example, segmentation, that could be more effective and can reduce all the risks associated with that. So the idea here is that there should be a plan, and there should be something that you know and should be formalized, that you know, okay, if I'm receiving this alert, I know how to act. And I think that's a key factor, and that's why we always recommend it, is that you have a plan and you know what to do when you receive the alert. And that plan's probably sometimes say, okay, you need to have a good asset inventory, because you need to know if that vulnerability applies to you or not. So, okay, but I know ahead of time that I need to get all this information. So it's not when something they say, hey, by the way, we just release this vulnerability and it's critical and you need to start acting right now, that you start looking for that information. But before that you have a plan and you know, okay, this is exactly how I'm going to evaluate if it's applicable. This is exactly how I'm going to see if I need to patch or I need to apply other control. Then you know exactly how to deploy that. If it's a patch, okay, I need to wait for the next maintenance windows, or if it's too important, I need to take the system off the network right now. And then there is how I verify that it's not affecting my safety or my production at the end, right? Because any change that you're putting in the system is another variable for their production. So you need to, after that, monitoring. So that's why, for me, this one is really, really important.
Absolutely, and a great outline for our listeners here. And for those keeping track at home, I did write down some notes. I want to quickly go over the 5 pillars that they just mentioned. ICS-specific incident response plan, go out and get a defensible architecture, OT visibility, multi-factor authorization for remote access, and key vulnerability management. Great outline there. Gentlemen, we're running short on time, so I'm going to try and cram in a few more questions if you don't mind. This one is interesting. What about turnarounds and projects? There's a lot of things happening there where you're not doing everything as normal. What about cybersecurity practices then?
Oscar, you want to take this one first, or would you like me to?
Sure. Okay, I will talk a little bit from my experience, and I will say that when there are turnarounds, you normally plan for your major overhauls. So, okay, there are several things that you can do in cybersecurity, several practices, right? One could be, and I think you will be tired by the end of this presentation, about segmentation, the defensible architecture, and some of them are actually very complex, right? And you need a lot of moving pieces. For example, if you are putting a firewall, then you need, okay, I need to make sure that the rules of the firewall are allowing the communication between the controllers that need to communicate. So there are several things that you need to do. So during those turnaround or shutdowns, there are activities that you can plan and say, okay, this is the time because the unit will be down and I have the availability to go and install patch, maybe make updates, apply logic, and make all these changes without affecting production, right? We want to keep production, that is one of the paramounts. But there are other activities that I think that they can be done, and those are probably project related. And I will say that when I think about project, I usually think about compatibility and where we want to go. So, for example, if you have a project and the project has a new device that you are adding to the network, then, okay, is this new device is adding some type of risk to my network? If I'm deciding that no, is there a specific plan for that? So there's those activities that I can do, that I can start implementing as part of my regular projects and my regular update projects, or when I'm increasing capacity, I can start putting this cybersecurity component into it. And for me, another one for projects is the cybersecurity language that is built into the contract, into the factory acceptances test, or the site acceptances test, or even just the agreements. Sometimes it's things like, okay, when you are adding this project, when you have this project and you are having a third-party vendor, are you looking at the cybersecurity component of it? If, for example, we just talk about the vulnerability, who is responsible to evaluate that? Who is responsible to decide what is the best course of action? So I think the practices and how it's implemented will depend a lot on the practice, but definitely there is opportunity in both in turnaround and projects to add a little bit of that. Mike?
Yeah, just quickly add on to that too. So turnarounds and projects are one of the ways where a lot of vendors come in and contractors. A lot of times they're coming in and they have to bring in software, maybe new project files and so forth for PLCs and DCS systems and you name it. The automation system out there, they may be touching it. What's going on here is a very vulnerable time within your system. So you have a lot of maybe laptops are coming in from outside. You have USBs, all those things where malware can actually be brought in. And so definitely need to ensure that you're aware of and tracking who's using what, making sure that you have a policy in place on what risks you're taking, if you're allowing that to occur or not, or if you're providing the folks access, providing them a laptop, in-house, different things like that. And also I found really works really well is having something on the permit, an operational permit. So if somebody is going to use a laptop in a RE building or out in the plant, that laptop has been scanned. It's it's not wireless and turned on, those kind of things, not dual home, so forth. Different things like that. I've seen it work really well where just a simple question that the operator on the permit can actually look at it and ask that question. Have you checked in with the responsible person at the site to use this electronic device and so forth? By doing so, you can really kind of, pull in a lot of those activities and make sure that when you go back to the startup process, you actually are starting out with a secure plant. So.
All right, I'm going to squeak one last question in. I'm going to challenge both of you to keep it to 20 seconds or less. So let's see if we can do this. What are your thoughts around increasing cloud connectivity for OT systems? Mike, go ahead, go first.
All right, so cloud is here, it's coming. The main thing about cloud is just understanding the data flows and understanding that cloud is just another computer out there that needs to be secured. And so, just making sure that you're aware of that system is being monitored and that you know how and where that system connects down to. It's another network to segment off. Oscar.
I think it's happening and it will keep happening. We will have more and more devices. I will challenge that before jumping into the cloud, answer the question, is really necessary, something that actually bringing some kind of advantage to the company. There are several ways to answer that question. It could be cost analysis, it could be different benefits, but also looking that, okay, every time I connect something or I expose something to the internet, there is also a risk. And at the end, it's evaluating is the advantage, is worth having this risk.
All right, Mike and Oscar, thank you so much for fielding all of these questions. Obviously, you are in the opportune field for yourselves because you were unflappable with all of these questions, and you really calmly and thoughtfully answered them. So I appreciate that. Audience members, did you like this presentation? Let us know your thoughts by answering our brief survey. It'll be posted to the screen in just a moment. Your candid answers are not only appreciated, but they will help us craft future events. Remember, this will be available on chemicalprocessing.com. Feel free to log in and view it again, or to encourage your colleagues to view it. We'll send out an email with that link as well. And we hope that you visit chemicalprocessing.com to gain access to even more tools and resources aimed at helping you achieve success. On behalf of Mike and Oscar and the team at Dragos, thank you for your attendance, and we hope you have a great day.